Imagine a fighter so advanced, so covered, that even the world's most sophisticated radar systems can't detect it. The X-44 MANTA, or multi-axis no-tail aircraft, is more than just a next-generation stealth fighter. It's a technological paradigm shift designed to dominate the modern battlefield. Developed by Lockheed Martin under strict secrecy as part of their famed Skunk Works division, the MANTA embodies the United States' push to maintain air superiority. It isn't just about speed or firepower. It's about creating a fighter jet with multi-dimensional advantages, a truly fifth-dimensional weapon designed to operate in every combat environment. From the atmosphere's edge to contested airspaces, deep within enemy territories. But what makes the X-44 MANTA so formidable? To uncover the layers of this aircraft's mystery, we'll explore its origins, the revolutionary engineering behind its tailless and radar-resistant design, the unmatched speed and agility it brings to the skies, the advanced cloaking technology that makes it nearly invisible, and its devastating arsenal of hypersonic missiles and potential railgun tech. This is the story of the X-44 MANTA, a ghost in the skies, the ultimate ace in the U.S. military's strategic playbook, and a true symbol of air dominance in the 21st century. Cold War shadows. The origins of the MANTA's concept. The roots of the X-44 MANTA can be traced to the Cold War's legacy of rapid innovation. In a world divided between the United States and the Soviet Union, military planners understood that air superiority was critical. The Cold War pushed the United States to develop not only faster and more agile aircraft, but also more elusive ones, able to penetrate Soviet radar undetected and execute precision strikes. This drove Lockheed Martin to work on some of history's most legendary aircraft, from the U-2 to the SR-71 Blackbird and the F-117 Nighthawk. But the X-44 concept demanded a level of stealth and maneuverability never seen before. It wasn't merely an extension of these earlier stealth projects. It was an attempt to solve a unique problem. How could the United States deploy a high-speed, heavily armed stealth fighter into heavily defended airspace without it being detected? The tailless design of the MANTA was a groundbreaking answer to this question. By eliminating the tail, Lockheed's engineers were able to create an aircraft with a radically reduced radar signature, an almost undetectable presence in the sky. Coupled with cutting-edge material science and sophisticated radar-absorbing coatings, the X-44 MANTA was designed to achieve complete radar invisibility. The MANTA was the embodiment of American ambition during the Cold War, a weapon that could change the dynamics of a conflict without leaving a trace. Lockheed Martin had not only built an aircraft, they had built a blueprint for future warfare, one based on strategic ambiguity and unpredictable, lightning-fast responses. The tailless design, a triumph in stealth aerodynamics. The MANTA's tailless design is a marvel of aerodynamics and stealth engineering. Traditional fighter jets rely on vertical and horizontal stabilizers to maintain control, which also create a larger radar cross-section. These stabilizers make the aircraft more visible to radar systems, essentially lighting up a target in contested airspace. In eliminating the tail, Lockheed Martin's engineers took on a radical challenge: to build the fighter that could remain perfectly stable and agile without the traditional control surfaces that have defined jet design for decades. The result? A unique delta wing, tailless structure that significantly reduces drag and radar reflection. This shape, paired with thrust vectoring technology, allows the MANTA to control its pitch, roll, and yaw solely through the direction of its jet exhaust. Thrust vectoring alone is a difficult feat, requiring sophisticated onboard computing power to adjust engine nozzles in real time and maintain balance at high speeds. By integrating thrust vectoring into its overall design, the MANTA eliminates the need for bulky stabilizers, enhancing stealth and giving it unparalleled agility. But the benefits go beyond stealth. The MANTA's tailless structure also contributes to higher fuel efficiency and a longer operational range, essential factors for deep penetration missions. In effect, the X-44 MANTA becomes not just stealthy, but also highly versatile, able to execute complex combat maneuvers with precision and speed, even at extreme altitudes and velocities. This combination of agility, stealth, and efficiency makes the MANTA a virtually unmatched adversary in the skies. Revolutionary thrust vectoring, a new era in maneuverability. The MANTA's thrust vectoring system is not just a technological feature, it's a game-changer in aerial warfare. In conventional aircraft, maneuverability is limited by the aircraft's physical structure. With the MANTA, thrust vectoring enables precise, almost instantaneous changes in direction, making it one of the most agile aircraft in the world. Traditional jets rely on mechanical control surfaces to make turns and adjustments. However, the MANTA's system directs the jet exhaust flow to achieve the same effects, allowing for complex, multi-axis control with minimal drag. The result is an aircraft that can pivot almost instantaneously, evading missiles and engaging targets from unexpected angles. In a dogfight scenario, the MANTA would have a significant edge, able to make sharp turns and rapid altitude changes that would be impossible for conventional fighters. This ability isn't just about evasion. It enables the MANTA to control the tempo of an engagement, positioning itself in ways that keep it out of an adversary's targeting system while maintaining offensive capabilities. Thrust vectoring also extends the MANTA's capabilities to extreme flight envelopes, low altitude, high-speed passes, or rapid ascents to extreme altitudes. This flexibility allows the MANTA to adapt to virtually any battlefield condition, evading both ground-based anti-air systems and aerial threats. As a result, the MANTA becomes not just a fighter jet, but a dynamic and adaptable multi-role combat aircraft. Unmatched speed and altitude, pushing the boundaries of supersonic flight. The X-44 MANTA's speed and altitude capabilities are designed to make it a true predator in the skies. Capable of reaching speeds approaching Mach 2, the MANTA outpaces almost all conventional aircraft, giving it a critical edge in both offensive and defensive scenarios. At speeds exceeding 1,700 miles per hour, it can strike targets and evade interception, disappearing before ground-based defenses or air patrols can react. Altitude is another essential factor. The MANTA is engineered to reach altitudes near 70,000 feet, higher than the operational ceilings of most modern aircraft and beyond the reach of many surface-to-air missile systems. At this height, the MANTA becomes an unseen observer, capable of gathering intelligence, surveilling enemy positions, and executing precision strikes with impunity. The high-altitude capability also allows the MANTA to stay out of reach of radar, blending into the background noise that traditional radar systems struggle to filter. To achieve these speeds and altitudes, the MANTA is constructed from advanced materials, including radar-absorbing composites and titanium-based alloys capable of withstanding the high temperatures generated by supersonic flight. The result is a platform that can endure extreme conditions without sacrificing stealth, a true blend of speed, altitude, and resilience that makes it a nightmare for any adversary. Parallax cloaking technology. Beyond radar invisibility. If stealth is the art of evading detection, then the MANTA's parallax cloaking system is the ultimate masterpiece. Designed to make the aircraft not only radar invisible, but also optically elusive, parallax cloaking utilizes a combination of fiber optic projectors and reflective coatings to mirror the aircraft's surroundings in real time. This means that, as the MANTA flies, it projects the sky, clouds, or ground beneath it, making it nearly invisible to the naked eye. The science behind parallax cloaking involves a sophisticated array of sensors that capture the environment around the aircraft, feeding data into onboard processors that project an image of that environment onto the MANTA's surface. This creates an effect akin to optical camouflage, rendering the aircraft a virtual ghost in the sky. Imagine an aircraft that could fly overhead without anyone on the ground noticing. This is the stealth advantage parallax cloaking brings. This technology is especially valuable for deep penetration missions, where the MANTA could evade both radar and visual detection, approaching high-value targets undetected. The combination of radar-absorbent materials and optical camouflage makes the MANTA one of the stealthiest platforms ever conceived, capable of conducting operations in highly contested airspace without leaving a trace. Parallax cloaking transforms the MANTA into an aircraft that's not just stealthy but practically invisible, a true phantom in modern warfare. Advanced armament, hypersonic missiles, and experimental railgun capabilities. Hypersonic missiles, a game-changer in long-range precision strikes. The X-44 MANTA's armament is anchored by a suite of advanced hypersonic missiles, which represent the cutting edge of modern missile warfare. These missiles are designed to exceed speeds of Mach 5 times the speed of sound, reaching over 3,800 miles per hour. At such velocities, these projectiles can cross vast distances in minutes, giving the MANTA an unmatched range in delivering strikes against high-value targets deep within hostile territory. Advanced targeting and pinpoint accuracy. Each hypersonic missile is outfitted with sophisticated guidance systems, including advanced inertial navigation and satellite-assisted tracking, ensuring they remain on course despite high speeds and long ranges. These guidance systems allow the MANTA to engage in beyond visual range (BVR) engagements, striking targets with precision from well outside the reach of conventional enemy defenses. High agility and evasive maneuverability. Unlike traditional missiles, which follow a relatively predictable path, hypersonic missiles are designed to make rapid adjustments mid-flight. This evasive capability makes it extraordinarily difficult for enemy missile defense systems to track and intercept them. With speed and maneuverability combined, these missiles not only reach their targets faster, but also evade existing missile defense systems that were primarily designed to counter slower, less agile projectiles. Thermal management and heat resistance. Traveling at hypersonic speeds creates immense friction and heat, which could destabilize or even destroy a conventional missile. To overcome this, the MANTA's hypersonic missiles use advanced heat-resistant materials, such as composite ceramics and high-temperature alloys, ensuring structural integrity during their high-speed flight. This thermal management innovation is crucial for maintaining the missile's guidance accuracy and explosive payload viability on impact. Payload versatility and precision damage control. Each missile can be equipped with a variety of payloads, including high-explosive, fragmentation, and specialized bunker-busting warheads, allowing the MANTA to adapt its offensive capabilities to the nature of the target. The precision targeting capabilities of hypersonic missiles also enable surgical strikes, minimizing collateral damage and allowing the MANTA to engage targets in populated or strategically sensitive areas without risking unintended casualties. Railgun capabilities. Revolutionizing silent, high-speed kinetic strikes. In addition to hypersonic missiles, the X-44 MANTA is rumored to be equipped with an experimental railgun system, marking a significant leap forward in airborne weaponry. Unlike conventional firearms or missiles, a railgun propels its projectiles through electromagnetic fields, accelerating them to supersonic speeds without the use of explosive propellant. Electromagnetic propulsion technology. The railgun uses two parallel conductors and a high-voltage electric current to create a magnetic field, which generates the force required to propel a solid metal projectile at over 4,500 miles per hour. This electromagnetic propulsion system is highly efficient and nearly silent, making it a stealth-friendly weapon that can engage targets from a distance without alerting enemy forces. Exceptional range and accuracy. Railgun projectiles travel at extremely high velocities, allowing them to reach targets across distances far beyond the capability of traditional cannons or guided artillery. Combined with the MANTA's advanced targeting systems, the railgun can deliver pinpoint strikes, ideal for high-value targets where accuracy and stealth are paramount. Reduced collateral damage. Unlike missiles that rely on explosive payloads, railgun projectiles achieve damage purely through kinetic energy. Upon impact, the projectile delivers an immense amount of force, creating localized devastation without the shrapnel spread or incendiary effects of traditional explosives. This makes it suitable for precision-targeted strikes where reducing collateral damage is essential. Compact and efficient munition storage. Railguns do not require the bulky warheads typical of traditional munitions, allowing the Manta to carry more rounds with less space. This increases its combat endurance and operational flexibility, allowing it to engage multiple targets in a single mission, integrating hypersonic and railgun capabilities. A dynamic multi-target arsenal. The combination of hypersonic missiles and a railgun gives the X-44 MANTA unparalleled flexibility on the battlefield. Each weapon system serves distinct purposes, providing the Manta with options to engage targets in a variety of combat scenarios. Long-range offensive strikes. Hypersonic missiles provide the Manta with the capability to engage high-value, distant targets, while keeping the aircraft at a safe distance from anti-air defenses. This is particularly useful for engaging well-defended enemy installations, command centers, or high-value aircraft like AWACS, Airborne Warning and Control System, planes. Precision close combat engagements. In close combat or contested airspaces, the railgun can be deployed for rapid, stealthy strikes. Since the railgun does not rely on an explosive payload, it minimizes the risk of detection from heat-seeking or radar systems that might otherwise lock onto a missile launch. Simultaneous multi-targeting flexibility. With a loadout that includes both hypersonic missiles and railgun projectiles, the Manta can engage multiple types of targets simultaneously, using hypersonic missiles for distant or moving threats while relying on the railgun for high-priority targets at closer ranges. This versatility enables the Manta to handle a range of mission objectives in a single sortie, reducing the need for support and enhancing overall mission success rates. Integrated combat systems and targeting synergy. The Manta's combat systems are integrated through a next-generation onboard AI that coordinates between hypersonic missile and railgun systems, optimizing target acquisition, priority setting, and engagement tactics. This advanced AI ensures that each weapon is used at the optimal range and angle, maximizing the chances of a successful strike. Predictive targeting algorithms. The AI utilizes predictive algorithms that analyze enemy movement and calculate optimal interception trajectories for each weapon. This capability allows the Manta to target fast-moving aerial or ground targets with high precision, especially important in anti-air or anti-armor scenarios where quick decision-making is essential. Adaptive threat assessment. When engaging multiple adversaries, the Manta's onboard AI assesses the threat level of each target and allocates weaponry accordingly. For instance, in a high-threat environment, with both aerial and ground targets, the AI might prioritize hypersonic missiles for distant air threats, while reserving the railgun for ground-based anti-air defenses, creating a balanced attack strategy. Data integration with network-centric warfare. The Manta's combat systems are designed to integrate seamlessly with network-centric warfare platforms, receiving real-time data from allied sensors and satellites. This data is fed into the AI, which enhances the targeting accuracy of both hypersonic missiles and railgun projectiles by providing a broader situational awareness. Future-proofing the Manta's arsenal, hypersonic advancements, and railgun upgrades. The X-44 MANTA's armament suite is designed with modularity in mind, allowing for future upgrades as technology advances. Evolving hypersonic technologies. As hypersonic research progresses, the Manta's missile systems are expected to incorporate advancements in materials and propulsion, potentially increasing speeds beyond Mach 7 and enabling longer operational ranges. Enhanced railgun capabilities. Future upgrades to the railgun system may include faster recharge rates, increased muzzle velocity, and the use of exotic materials for projectiles, such as tungsten or depleted uranium, which would further enhance penetration power and effectiveness against fortified targets. The X-44 MANTA's armament of hypersonic missiles and railgun technology places it at the forefront of modern combat aircraft. With a combination of speed, stealth, precision, and adaptability, the MANTA is equipped to dominate any aerial engagement, penetrate the most fortified defenses, and execute high-stakes missions with surgical accuracy. This combination not only provides a unique strategic advantage, but also exemplifies the cutting-edge advancements driving the future of air warfare.